Today we are going to talk about statistical measures used to describe clinical tests. Here on this table we can see that on the x-axis we have health and disease, and on the y-axis we have a positive test and a negative test. From this we can see that there's four variations that can occur. We can have a positive test in disease, which is labeled a true positive. We can have a negative test in health, which is labeled a true negative. Next, we can have a positive test in health, which is labeled a false positive. And finally, we can have a negative test in disease, which is labeled a false negative. The first statistical measure is positive predictive value. Positive predictive value looks at all the positive tests and determines how many of them are true positives. So the equation for this is true positives over all the positives, which includes false positives plus true positives. So again, positive predictive value looks at all the positive tests. Next we have negative predictive value. Negative predictive value looks at all the negative tests. Now this wants to find out how many of those negatives are true negatives. So the equation is true negatives over false negatives plus true negatives. So again, negative predictive value looks at all the negative tests and determines how many of them are true negatives. Next we have specificity and sensitivity. An easy way of remembering the equations for these two are as follows. A test that is 100% sensitive has 0 false negatives. 0 false negatives. So N in sensitive for 0 false negatives. So the equation for this is true positives over false negatives plus true positives. So if you plug it in here, we can see that if we have 0 false negatives, we will have 100% sensitivities. So N in sensitive for 0 false negatives. Next we have specificity. So a test that is 100% specific will have 0 false positives. The P in specific for false positives. So the equation for this is as follows. True negatives over false positives plus true negatives. So the P in specific for 0 false positives. If you plug it in here, we can see that if we have 0 false positives, we will have 100% specificity. So again, to recap, we have positive predictive value that looks at all the positive tests and determines how many of them are true. Then we have negative predictive value that looks at all the negative tests and determines how many of them are true negatives. In sensitivity, we know that if it's 100% sensitive, we will have 0 false negatives. N for negative, 0 false negatives. In specificity, we know that if a test is 100% specific, we'll have 0 false positives. P in specific for 0 false positives. Thank you all for listening.